All right, let's get started. Welcome to Radio Telescope Observation Party, July edition. I hope everybody still has their fingers from 4th of July. The couple things, we have the Eastern Conference in August. It's the time to actually sign up for the local is running short. We're not going to accept any applications, I think, after July 15th or something like that. The online will also have a deadline just because we need to be able to figure out who's online, get them the links, etc. So if you're going to do online or if you're going to go try to make the event, sign up now. This is one of the hats that we've got. SARA hats, we got SARA shirts. That's saragifts.org is our new site for that. And so that's working out well. A lot of orders from that. So it's one of our new innovations that seems to be working very well. It takes very little time for us to manage it. We almost just have to count the PayPal going in and out, which is pretty automated. Let's see what else we got. Okay, that's all I've got. Let's start at the Edward.
Yeah, hello. Oh, oops, stop my video.
We can hear you.
Yeah, there we
There you
are.
are.
Hello. Okay, yeah, I got a couple small things to share. So can I share my screen?
Go ahead.
All right. Let's see. Share. Yeah, can you see this?
Yes.
All right, great. Now, let's go to. Okay, so yeah, a couple of small updates, thingies. So I've still been working on the telescope mount that I told you about in the last few episodes of the Radio Telescope Observation Party. So yeah, nothing really, no big news on this front, except that I've been just gradually working on it. So I just finished integrating the motors, the stepper motors, and the belts and pulleys and everything. So all the mechanical components are pretty much finished. I'm working on building in the electronics in neat boxes. So hopefully I will be able to test everything soon. And then I'll be doing a little bit more of an elaborate update based on how the testing goes. So I've also been continuing observations of Westerhout 49 at 22.2 gigahertz. Yeah, so at the moment it's a bit inconvenient because in this season it culminates right in the middle of the night. Hopefully that's but still I managed to do monthly observations of it. So but nothing really big is happening in a way of large changes or flares or anything. So I'm not really going into detail about that today. What I will show you something about some new observations is from the 25-meter Dwingelo telescope. I actually visited the Dwingelo Observatory again 2 weeks ago and did some observations there together with Tamoyan and Thomas over there. Yeah, we had a great afternoon and got some new observations at the OH lines. So yeah, some of you may remember, but some of you may not. So yeah, very short summary. So the Dwingelo telescope is this 25-meter dish in the northern part of the Netherlands that was built in 1956, if I remember correctly. So it's quite a historical instrument from the early days of radio astronomy, and currently it's being maintained by a volunteer organization known as cameras. So, and they made this telescope essentially operational again. So it's currently mostly used for amateur radio stuff like EME, for example, but also communications with moon satellites, that sort of thing, and also some radio astronomy. So mostly just hydrogen line, but we are now exploring or starting to explore the OH lines at 1.6 to 1.7 gigahertz. So yeah, the first observation that we did this time was we started off with Cassiopeia A, which is a strong continuum source. There's two reasons for this. First of all, we wanted to check how well the Wingelow telescope performs at the OH line frequencies compared to the hydrogen line. And well, we haven't had time to really process the data, but we could already see that it was quite bad actually at 1.6 to 1.7 gigahertz. So at the hydrogen line at 1420 megahertz, when we point the dish on source, we see a jump of about 6 or so dB in the received noise power. So that's quite a bit actually. And then when we did the same experiment at 1.6 and 1.7 gigahertz, we only saw an increase of about 1.7 dB or something like that. So it's really, the sensitivity at the OH line frequencies is really much lower. But still, this 25-meter dish is quite adequate for some OH line observation work. So yeah, the second thing that we wanted to try is to see if we could detect the absorption lines. So yeah, at 1420 megahertz, this is quite easy for such an instrument. So you can see that in the plots on the upper right, those are the absorption lines of the hydrogen, at the hydrogen line, 1420 megahertz, they're quite obvious. And we also managed to detect the absorption of the OH molecule at 667.4 megahertz. Although, yeah, of course, these absorption lines features are quite a bit weaker than at 1420 megahertz. And what was interesting to see is that also the absorption lines of the OH molecule are quite a lot more narrow. So next, we did some observations of W3OH. So this is a hydroxyl maser in a star-forming region, and we actually observed this source earlier, back in January. You can see the plot for that earlier observation in the upper right corner. And yeah, we basically wanted to do this observation again to see if there are any changes in the shape or in the profile of the spectrum. And as you can see, it pretty much looks exactly the same. So there's not really any major changes. It's still possible, of course, that there is a change in just the general intensity of the source, but we cannot detect it at the moment because we don't have a procedure to actually do some real calibration to flux density. Although it might be possible now that we have those observations of Cassiopeia A at least as one fairly well measured continuum source that we can at least make an estimate of the flux density at some point, but we haven't really looked into that so far. That's something that we could do in the future. So OH104, it's another source. This is an OH-IR star. So this is one of those stars that has it's a red giant star essentially that has a very thick shell of gas and dust around it. And it's also hosting OH masers. And what's interesting about these stars is that they have a very distinct double-peaked spectral profile, and that's because the far side of the shell is receding. It's moving away from us as the shell is expanding, and the closer side is moving towards us. So from the far side we get the red-shifted peak, and from the side that's closer by we get the blue-shifted peak. And yeah, this particular star, we also managed to detect these two peaks at around -40 and -10 kilometers per second, although the emission was quite weak, and it was quite tricky to detect with only 2 minutes of integration time and fairly poor sensitivity. But still successful nonetheless. We got a pretty good spectrum actually of VY Cadence Majoris. This is another OHIR star. It's actually a red supergiant star. It's quite an interesting star. Unfortunately, it's at our latitude, it's only culminates at a fairly low elevation of around +12 degrees. So it was a bit challenging to time our observation in such a way that we are like not looking at treetops, for example. Despite this very low elevation, we still managed to get a fairly decent spectrum. So you can see the redshifted peak and the blue shifted peak as well. The redshifted emission is quite a bit weaker in this case. And you can also see that it's quite an interesting spectrum which is actually composed of many different smaller peaks which kind of overlap with each other. It's kind of unusual. And we also managed to detect its source even at 1667.4 megahertz. As you can see over here in this spectrum. So we got a positive detection, just barely. Signal to noise ratio was not very good, and I needed to reduce the spectral resolution quite a bit to get a decent signal to noise ratio. But yeah, it was interesting to see that we could detect the source essentially at 2 different frequencies. So yeah, that's our observations that we did at Wingelo 2 weeks ago. Yeah, that's it really. I've not really anything more to show this time. Yeah, and once again, I want to thank Jan and Thomas for letting me join the observation session. We had a great time. So yeah, if there are any questions, just let me know.
Ed, can you go back to your absorption towards Cassiopeia on the OH, please?
Yeah, sure. Here you go.
Okay. What strikes me a bit about, but this may be a matter of your resolution that you have, is in the hydrogen you have a single line at around 0 kilometer per second, then you have the double line from this one. And that doesn't show in your absorption spectrum. And it actually is there. There is a feature in the absorption. Let me just share my screen a moment. Oops. Can you close so that I can? Great.
Yes,
thanks.
I just closed.
Okay, can you see that?
Yes.
Okay. This is the absorption of OH, or actually it's from the 3 different transitions, 1612, 1665, and 1667. The 1700 is always a bit difficult because of RFI. And what we found is that actually what shows as a double absorption line around 50 kilometers per second is if you look at the absorption on OH, where the lines are narrow, it's actually a triple absorption. So it's best seen in this transition. And another feature that we came across, and we're not really certain whether that's an instrumental artifact. We did I don't have it right at my hands. We did a very high resolution of this absorption line, and we found that there's a slightly different, at least from our measurement, there's a slightly different velocity for the 3 different transitions, which is a bit of strange thing because you would expect that it's the same cloud moves with the same velocity, even though it's a different transition, but it's still the same molecule. So we're not certain whether that's an instrumental artifact. I can't show it right now because you need to go to higher resolution. So I was wondering whether you could maybe try that at some point in time to go to higher resolution. Of course, you need a lot of integration time to get a reasonable signal to noise ratio, but that's something that's been bugging me all the time. Is that an instrumental artifact or is it real? Okay, that's
yeah, thank you. Yeah, about the absorption feature at minus 50 kilometers per second, I think actually that we are seeing it as a single feature in our spectrum because of like our rather low spectral resolution, and also because of like a very poor signal to noise ratio. So there's quite some noise that's making it difficult to see really those to pull apart these features. It would be interesting next time to do a longer integration run. Hopefully at some point we will be able to, if ever a new feed gets built for the Dwingelo telescope, we will be able to have better capabilities at the OH frequencies.
Yep.
That's something that we really, a capability that we really would like to have there. And then we could really like do those kinds of experiments, as you mentioned, like do like very high resolution spectra of these absorption features to figure out what's going on, maybe with like those velocity shifts that you mentioned. That would be very interesting once we have the capability. Yeah, thank you.
Okay.
Well, now I've got Edward and Wolfgang on at the same time. For the newbies and some of us old bees, can you explain the absorption line, how an absorption line gets formed, as opposed to, we normally see a hydrogen as a peak, and now absorption line goes the opposite direction. Can you guys explain how that works, and and how you actually pick it up as an amateur here?
Yeah, maybe I can give a comment on that. The absorption occurs if you have a bright source and you have between the bright source and yourself, you have, in this case, for example, hydrogen. And what happens is that the hydrogen gets excited by the radiation it receives from the bright source. Of course, this radiation excites the hydrogen in this case, and it's re-emitted, but it's re-emitted in all directions. So the net balance is that you lose energy in that certain specific spectral range. And that is the same effect as the Fraunhofer lines in the spectrum of the sun, which is exactly the same. You have the bright sun, and then you have material that absorbs. The trouble with that for an amateur is that if you have a small telescope, you have a fairly large angle of observation. So the emission of the hydrogen becomes so massive, so dominant, that the absorption feature is not, you are not able to see it. Whereas with a 25-meter dish like the Dwingelo and ourselves, you actually have a much narrow beam, so you can really concentrate on where the absorption happens. And I'm not sure where exactly the threshold would be to see actual absorption lines against Cassiopeia. That's probably for hydrogen. I'm talking about hydrogen. That's probably something like 10 meters or so. However, for OH, where you don't have a bright emission, I would say you could eventually also see it with a smaller dish because it's not overwhelmed by a bright emission of OH. We haven't tried it with a smaller dish yet, like a 3-meter dish. It's probably going to be tough. You need a lot of integration time because it's a fairly weak feature, but should be. Eventually, it's possible. I don't know.
Okay, thanks. Any more questions for Edward?
Yeah, I kind of have one for both Wolfgang and Edward. When you were discussing the possibility of the slightly different velocity for the different absorption lines, it makes me wonder if it turns out that it's not an instrument artifact, but it's actually real. Would that indicate that there's dense structural shells in the cloud that are at different radiuses from the center of the star itself, and so you have slightly different velocities for the dominant part of the absorption or emission?
It's kind of difficult to find a reasonable explanation. Typically, you would expect that you have a cloud of, in this case, OH.
Mm-hmm.
Every molecule in that cloud has the transitions which are intrinsic to OH. and they should show up at the same velocity, because the transition, you would not expect that the transition probability of the different lines is anywhere different depending on the velocity. So that's kind of strange. So I'm inclined to think about that this might be an instrumental artifact, because it's really very, very narrow. We're talking about a couple of tens of hertz there. So it's really, really at the limit where you can say. The only thing is, I sort of accidentally saw it because I tried to go to the extreme high resolution. And then I just found that there were slightly different velocities or different transition frequencies. I would say 80% it's an instrumental artifact. Maybe 20% is something funny.
Okay.
It would be interesting to check this with like the Dwingelo telescope with a different system. So if it is an instrumental artifact, it will be like different between like one radio telescope and the other. And if you're seeing like the exact same shift, then something funny may be going on. But
yeah, if it would be,
I don't
if
think
you would see the same thing on, let's get in touch or discuss that with Thomas and yourself and the team at the Dwingelo telescope, whether it's doable to do the same experiment and see whether you find the same thing. If you find the same thing, I don't think it's an instrumental artifact. If you find something different, then it's our instruments.
Oh,
Rich, you're muted.
I just noticed that. Thank you, Edward. Great job. Wolfgang, you're next. What you got? Anything going on?
Yeah, there's really nothing new from our side. We've been observing a fast radio burst, a repeat fast radio burst, which was first reported in, well, it was detected in February, and we were not successful so far. We've spent something like 130 hours of observation time on that particular repeater, but we didn't see anything. So we're scaling down on our observation on that one. There was a brief attempt of yet another fast radio burst, which was reported just a few days ago by the Mercat team in South Africa. That's a source that just barely comes above the horizon for us. So we took a quick shot at it. And again, we didn't see anything. So there's nothing exciting at the moment on the front of the FRBs. We're waiting for the next one interesting enough to show up so that we can go after him big time. And yeah, I guess that's pretty much all I have at the moment.
Okay, great. And Vanessa, how's your project going?
It's going good. I'm currently working a little on the UV plane and how that's going to matter for the imaging process, but that's still in baby shoes. So still working on it to get a picture at the end.
And Vanessa just submitted an article for the next journal. So hope you guys will see what kind of stuff she's doing. Great. And so let's get Dimitri.
Hi to all. I'm also about masers, but not only masers. With some problems arise. In just a moment. Do you see the screen?
Yeah, we see it.
Okay. I'm continuing working about 2.4 meter dish designed by Radio Whiskey 3 Bravo Papa 4 millimeter wave. I expected very high efficiency, about 0.7, but measurements by solar measurements of sun flux, it seems do not confirm 0.7, somewhat lower, 0.65 of aperture efficiency. System temperature is about 120 kelvins for the system at 7.6 gigahertz. The problem is some spread of solar data from Vermont's observatory. My observation time is out of its window of observations. End of day of observations is about 9:10 o'clock of UTC, but my observations time is about 11 o'clock of UTC. And as you can see, at the end of the day of observations, we see some fall of data. We see some fall of data from Vermont's observatory. I left only almost 9 gigahertz and 5 gigahertz data, because my frequency is between them, and I can interpolate to get a proper solar flux for calibrating my antenna. It seems an instrumental error from Vermont's observatory, and it's better to take data for calibration somewhat earlier than end of date. But and in that moment, antenna beam, half power beam wise, is about 1.3 degrees. Solar size is about 1.3 degrees. They're comparable, and correct calculating of antenna temperature from sun need to be used at the beam filling factor for correct calculation of expected antenna temperature. But I my first aperture efficiency was made in the days. The data was the day was missing. I just interpolate the data from 15 July to 17 July. Maybe some errors in interpolations, but first obtained aperture efficiency was 4.7 this is first light W3 masers, very bright source, and I can see it on the screen of receiver, less than 1 minute of integration. Next successful observations, 26 June, Cepheus A maser, already I have taken already new aperture efficiency, confirmed by at least 2 measurements in 22 June and 26 June. And you can see bright red shifted peak and more weak blue shifted peak of the spectrum. No, that's all for today. One note, integration time 1 hour, also 1 hour, and backgrounds was heated by fifth order polynomials as we discussed it in Google group. Noise flow is some tired, not too flat with polynomial fitting, but really noise peak is really lower with polynomial fitting. That's okay that's all for today. With some questions.
Any questions for Dmitry? Great stuff. Looks like you're getting that thing tuned up.
Well, thank you.
All right. Let's go to Andrew.
Hi. I haven't got anything to report this time.
Okay. All right. Thanks. Jason.
I don't have a whole lot. I did dust off my old corner cube reflector and did some Milky Way hydrogen observations with it. Basically, the reason was I was there was somebody on the Facebook group that was in the UK who was trying to get their first Milky Way hydrogen line system working, and they thought they had observations, and it looked to me like they had a good peak, and so I was just trying to kind of duplicate their results with a similar similar antenna pattern. My corner cube has a pretty wide beam width, and so I figured it should give me similar results to what they had. And yeah, the only other thing I have to bring up is I was kind of curious. I know that Jay was mentioning that the presentations we're doing it if we're like I'm speaking at the conference in August. He mentioned that our presentations should be kind of a short summary that then kind of is a sales pitch for the paper. And my question is, where does the full paper end up being made available? Is that in
It's in the proceedings.
Okay, that's what I thought.
Right. So you have to get that to the proceedings and and if you have slides for that, you can also add those in the proceedings too.
Okay.
And the only limitation on your presentation is time.
Uh-huh.
So put
Yeah.
the slides in that when you explain it and you sort of do your test run, that you have 5 or 10 minutes or whatever for questions at the end, at least 5 minutes.
Yeah.
And that's it.
No, I already turned those. I turned both of those in, back at the very end of June. Did both the paper and the presentation slides just go to Jay, and then he sends them
Jay's putting the proceedings together.
Okay, all right. So I sent them to the right place then. Okay, good.
Yeah. If you have any concerns, just reach out to Jay and make sure he's got them. And that's always. I mean, that's actually a plus for the guys. I put a couple of these proceedings together, and if an author comes by and says, "Hey, are you sure you got my stuff?" It's always a good double check that you go check it. So go ahead and check it with him if you have any concerns, and he'll check it, and you'll be good to go.
Yeah, I'll just double check with him because I sent, way back at the very beginning of June, or I think even maybe in May, I sent a preliminary kind of like draft version, but then I sent the finalized version just at the end of June, right before the first result.
Sure. You're overachieving, getting that in early, which is good.
Well, yeah, it said that the deadline for the final one was July 1st, so I was wanting to get in ahead of that.
Yeah, that's it. Always appreciative.
Yeah.
All right. Thanks, Jason.
Yep.
Now Jerry Taylor has this background in the back that Ted picked up, and I wasn't sure whether his is, that's what my grandson does to our wall, or it's something in hydrogen. So Jerry, explain your background.
Yeah, I've spent the last couple of weeks wrestling with spastic USB ports, busted tripods, and other things. Finally, I kind of got things straightened out. So I purchased one of the kits from Alex for that plate Yagi that he just posted all the technical information on and put it together. And I got to tell you, after assembling it, I threw it on my Nano VNA and I got a SWR of 1.1 to 1. So that's I was happy with that. So I've been using that Yagi, and the fact that I used ezRA on one, I think it was like an 11-hour drift scan that you can see in the background there. And I'm still I'm kind of at the point now as a newbie where, yep, I can detect hydrogen, but then I just got to figure out what all these pretty pictures mean. So that's kind of where I'm at with ezRA. I do have I'd like to share a graph. Can you see that graph okay?
Looks good.
Oh, okay. Last night I was able to get a 12-hour drift scan. And I guess I got some questions. It was basically pointed at zenith, or as close as I could get. I had to cobble together a way to mount the antenna so I could get it pointed somewhere near zenith. But I guess my question is, after I did the drift scan with SDR sharp and IF average, I've got these areas here where I've what is causing this noise, or is there some sort of drift in the gain of the SDR, or can anybody explain what's going on there? I can't seem to get an offset that'll give me a good baseline.
So the SDR sharp with the IF average plugin allows you to get a background to subtract from your other measurements. So now you kind of get a relative measurement. And this simply shows for some frequencies that your baseline was kind of higher. So you get negative power somehow, right?
Yeah. Tell me, so that
Indeed, it could change over time. That baseline is at the beginning of your measurements, and then you take a bunch of measurements, and that's over time. And the electrical characteristics of your system can change over time. I'm stunned how fast it can change. It just kind of jumps around. And so it would be nice to even have more of those baselines or references to compare to. That's what ezRA attempts to do.
Oh, okay. So again, so there's nothing, what's the right word I want to use here? Substandard about the system. It's just a characteristic of the hardware that I'm using that's causing this negative power.
My impression is Alex sees these same things, and so he takes some point on the left, some nice frequency, and throughout time, he adjusts that spectrum vertically up or down so that that one point on the left, some frequency, remains the same value, thereby adjusting for this temperature drift over time. And that improves the picture a lot better. So he does further analysis than what I think you're showing.
Okay, yeah, this was just very basic. You know, 20 times the log 10 of, the value, and then I threw in an offset to try and get it somewhere near zero. But that's what I wound up with. But if I'm interpreting things right, I mean, I can see the, the drift scan starts over here. I was trying to pick up Cygnus A. I know there's a pretty broad beam on that antenna. It's like 28 degrees. So I assume that at this particular point, Cygnus must have been inside the beam, but I can see I'm seeing Doppler shift. Looks like a second arm of the galaxy. Is that all? Am I correct in those assumptions?
Well, maybe I have a comment to the signals piece. I think this is sometimes a frequent misunderstanding. What this essentially means, you're looking at the hydrogen towards the area of Cygnus, but you're not seeing Cygnus itself.
Right. Yeah.
Yeah. So I hear that frequently. They say this is Cygnus. Well, it's actually not. Cygnus is somewhere, some weak background signal. It's just the direction. And that's good enough. I mean, fair enough saying this is a hydrogen spectrum towards the direction of Cygnus, but it's not Cygnus itself.
Is it safe to say that since I'm pointing in the general direction of Cygnus, that you're naturally going to get a stronger signal? I mean, is that valid?
Actually, Cygnus itself doesn't play any role in what you're seeing. It is just a certain direction, and in that direction you have hydrogen. And you see the spectrum of the hydrogen. And yes, Cygnus is in that direction, but the source Cygnus A itself, you don't see.
Oh, okay. So it just happens to be a stronger signal of the hydrogen coming from that general vicinity. And Cygnus A.
Well, it's a part of the sky where you have a strong signal because you're close to the galactic plane. You could look at different parts of the galactic plane. You're also getting a strong signal. And it's fair saying, okay, this is towards Cygnus, but it is not Cygnus itself.
Okay. All right. I appreciate that.
Yeah. What I found too, when I first started doing Milky Way scans, is that you find that when you look at the optical image of the Milky Way overlaid on like the stellarium plot and showing where you're pointing, you find that it's actually the strongest signal is often in the dark part in the middle where the dust lanes are actually causing a dark shadow in the Milky Way. But the hydrogen line radio signal gets right through all that dust, and so that actually a lot of times the strongest signal is not where the brightest optical signal is, because you're right in that center of that dust lane, right in the center of the plane of the galaxy.
So
And yes, indeed, in the direction of Cygnus, you're looking across the galactic longitude where you definitely see at least 2 or 3 peaks. So this definitely corresponds to what you would expect.
okay.
Yeah. Having said all that, I mean, you have a nice signal. You shouldn't be too scared about the baseline variations. We have lots of baseline variations typically. So just sit back, relax. It's a good signal.
Okay. Yeah, my OCD doesn't like the negative power on there, but okay.
Yeah, well, and what you find too, like when you get into really low level signals, like what I'm doing with the external galactic sources, the amount of the vertical scale is so small that the background fluctuation becomes really significant. And as some of the other observation reports from other people, they when you get into that realm, you start using curve fits to flatten it. So you'll use maybe a linear fit or sometimes up to a 3 or 4 or 5 or 5th order polynomial fit to flatten the background, and that usually works. But you have to be careful too, because you can introduce false things into that. I try to use the lowest order polynomial fit that will flatten it nicely in the area that I care about. And what I also found was, I kind of started doing that on my own, and then I looked at some professional surveys that were being done with really big dishes, and they were using that same method to flatten their background. So it's I guess it's standard practice. But
okay. The other thing I was wondering, I did a 12-hour drift scan, so I've got 144 text files from IF average, and I just took one at the beginning, one where I thought would be a peak, and then one at the end of the scan, and plotted them. Is there anything that I could do with that 144 text files that would be of interest, or not?
Sure. Like I work regularly with those numbers of text files from IF average. Yeah, I've actually done some coding for this, but it's nowhere available actually. So maybe you could use ezRA for this. I have no idea. I haven't used ezRA, so you have to consult the expert on that.
Indeed, there is a converter called ezCal IF average, I think, AVG, that we can use to take your .text files coming out of that process and convert them into vertical lines, one per sample, just like you have behind your head there.
Okay.
So yeah, you can take your data from IF average and convert it over and push it into the ezRA format, and then let ezRA grind on it. That was the general idea. I don't mean to push too hard, but I offer that opportunity.
Oh, okay. Yeah, that's I'm kind of going back and forth between IF average and SDR sharp and ezRA, and trying to get a idea of how they each work. So yeah, that's helpful. Is that ezCal IF average that comes standard in the package?
Yep, it's in there.
Okay.
Beware, it's pretty ancient code. It's kind of picky, but it's intended to eat a whole directory of .text files from the IF average process.
Okay.
And provide you one .text file in the ezRA format.
Okay.
So
if
you have problems, please email me. It
okay.
may need help.
If you're handy at coding or writing scripts, you could easily take that stuff and convert it into a nice big CSV file and slurp it into, I used Excel and just did a 3D graph and had this like mountain range basically of the signal changing over time. You could see how the signal was shifting. A lot of the red shifting and blue shifting was due to the movement of the Earth, but it's kind of fun if you're handy with coding.
Hi, it's Andrew here. Just to say that I've done it with the IF average and turned it into ezRA files with the help from Ded there. Yeah, I mean, it's just wonderful. It won't just take you 12 hours. It'll take the next 12 months worth of data if you want to produce it in this way and turn it. And then whatever you do with it, it'll churn out 250 graphs for you at the end. So if you want something else to try and work out what on earth's going on, look at the 250 graphs churned out by easy radio astronomy. But it's pretty impressive stuff. But if you go onto my website, which is astronomy.me.uk, you can see many examples of the sort of stuff that ezRA produces.
Okay.
Produced with IF average files.
Yeah, correct me if I'm wrong, Ted, but doesn't ezRA also have a utility that will correct for the VLSR shift to allow everything to be in local standard of rest?
Exactly. That's one of the many stages. It takes all these samples, then it kind of compares them to each other to try to highlight the hydrogen, either by looking at the frequencies, we'll mostly look at the frequencies that don't have hydrogen, and therefore highlighting where hydrogen is. That's the hydrogen snake behind his head there. Mm-hmm. And then there has to be an adjustment. Sometimes you're on the front of the Earth looking out, and sometimes you're on the back of the Earth looking out its rear view window as it's going around the sun. And so velocity gets changed. And so that's part of ezRA too. For your antenna pointing position, it does all the calculations and then makes an adjustment and pushes it through the process.
Cool. Yeah, I thought so. I thought that was the case.
Or you could turn it off, or you could turn these things on, or you can change the filters. So there are a lot of knobs and switches, but I try to provide defaults at least for a start.
Thanks, guys. That's all very helpful.
And I must say, ezRA needs to be improved in many ways. If you want to help, sounds great.
Okay. Right. Got anything else, Jerry?
No, that's it. Thank you.
Hey, good stuff. Let's see. Ted.
I have one picture to show. Let me push some buttons.
Yeah, we see your antenna.
Hey, Ted, you're on mute.
There we go. Okay. Pardon me. I've been chatting away, talking away. ezRA, sure, needs help. If you want to help me improve it, that'd be great. Let's make it better. ezRA indeed was updated back on June 16th, and here we're talking on July 7th. So go get the latest stuff. In theory, it was an upgrade of many things that finally I got around to posting. This is a picture of some of the high school students I'm working with this summer. They built in Disk Yagi, and they mounted, and then they're seeing things as well. They're up to making 3 of them so far. I hope to get 4 of them out of them. We'll try to make some array. We'll start doing some at least additive interferometers, trying to explore new ideas. How can we make a smaller field of view for these antennas, a smaller beam width in a cheap way. That's the news from here. Questions?
I have a question. What are you going to be observing with the interferometer? I understand that doesn't work so well with like hydrogen gas, but are you looking at particular targets?
We're studying the antenna's beam pattern. If you add up two of them, what does its weird beam pattern do and things like that? And we get fringes and all that good stuff. But the best source at this point is the somewhat point source of a sun. So we'll give that a try and learn more about the antenna. Once that's improved, then if you point it at hydrogen, I suppose you're looking at a smaller part of the sky for hydrogen. And that's the whole idea. Let's try to make a bigger dish out of small, cheap elements.
Okay, thanks.
Thanks.
Thanks, Ted. Let's see. Skip Crilly.
Hello. Can everybody hear me okay?
Yep.
Okay. Yeah, I guess the news is I got a paper was just announced by Archive a few days, about a week ago. And this is a follow-up. It's a replication of the data from the 5th Archive paper that I've written on the narrowband pulses, the pulse pairs that I'm seeing with the interferometer, the two 10-foot dishes on my farm. And just one plot here is, so the two observation runs that I did were 46 days and 61 days. So 61 days was in the first paper that was back in April. And then this one is a 46-day transit looking for pulses. And then I plot the Cohen's D, which is a statistical measure of effect size across right ascension. And you can see there's a spike in the 5.1 to 5.4 region, which is where we're looking, which is for the 05 data, observation 5 data, which is the April paper. And then in this paper, the lower plot is 06 data using the same filters. So these are pulse pairs that are narrow bandwidth, 3.7 hertz bandwidth, offset by some frequency, which I set the limit to how far that offset is going to be, seen on both elements of the interferometer above an SNR threshold. And then I measure the count of those pulses in right ascension bins that are 0.1 hours in size. And that count can then be subjected to an effect size where you can say, well, what's the count in this right ascension bin? What's the count of those pulses in this other right ascension bin? And then are there any anomalies in the right ascension bins? And those show up as this Cohen's D plot that is shown here. So this is just leading to the same thing that I've been seeing since 2018 when Rich first proposed, the idea we use two dishes, that there's something strange about these pulses in that particular right ascension direction. And I'm trying to figure out what they are. So one of my further work items is to refine the filtering that I'm doing so that I can look for shorter periods of time to see these statistical anomalies that are pretty noticeable. I mean, these are in the order of 3 to 4 standard deviations, which each one of these plots has a chance of being due to noise, about less than 1 in 1,000 chances, doing random noise, additive white Gaussian noise. So that's the update, and I turned in this paper to Jay. So it's going to be in the proceedings, and then I'm going to prepare some slides. I haven't gotten the slides. They're just barely started, but I'll get the slides in, and we can talk about this at the at the conference. It'll be a lot of fun. I'm trying to get to the bottom of these strange pulse pairs.
Okay, great. It's scary if you actually get to the bottom of it.
Well, I hope somebody else does first, because I like my life the way it is now.
That's right. You'll be infamous. Okay. Thanks, Skip. Let's see. Don Latham.
Howdy. Nothing from here. Sorry.
Okay, thanks, Don. Dean.
I don't have anything from here. I've been studying quantum mechanics and standard models, which represent and the elementary particles it represents for the last few months. So that's all.
So my question to you is: this amateur radio astronomy harder or easier than that?
Well, I'm trying to do it all on my own, and I'm diving into it real deep, and I get a little more dense. I don't know, it's my age or just that I'm trying to do it on my own, and that's really a problem. But both of them are difficult, so don't think anything else. Okay.
No, thanks, Dean. Doug Harris.
Hi guys, I'm new to the group, so I guess I'm the newbie. I've just started to get engaged with this. I don't really have anything to offer today. I've been working. I've recently retired. My background's electrical engineering, and I worked in the display technologies from cathode ray tubes all the way to OLED displays, and so that's kind of my background. I've been involved in amateur astronomy, optical amateur astronomy for a while, doing some work at the Stewart Observatory in Arizona. We have an adult astronomy camp twice a year down there. And this year I'm trying to get them engaged in doing some things with the Arizona Radio Observatory also, so we can bring that into the mix of what we look at. So just drinking from a fire hose today, but glad to be here.
Thanks, Doug. Yeah, and anytime you want to interject with some astronomy knowledge, I think we got as a bunch of engineers who like to build stuff, and then you got the astronomers who they don't know. We don't know a lot about astronomy, and more engineering than astronomy. So you see an astronomy topic to bring up, bring that up.
Sure will. Thanks a lot, and I appreciate the welcome. Yep.
Okay.
Something that I was thinking, Doug, I want to, since I've been trying to detect hydrogen's spectral signals from other galaxies, it might be fun to try to collaborate at some point and put together side-by-side amateur captured astrophotography in optical side by side with the hydrogen spectrum.
Right. Yeah,
and
I think that
they're
would be
both they're both amateur data, which would be
right.
Yep.
Okay.
I was trying to sneak in there that there's a nova going on we should know about too. The star T in Corona Borealis, and on spaceweather.com or .org, folks, in the top right, there's kind of a highlight of it, of the latest news. It should pop any day now, 40 years from the last time it did it. 80 years from the last time it did it. And looking up in the sky, we should be able to see it with our eyes when it pops.
Ted, do you have the coordinates for that? Maybe that could be a goal of everybody to aim their antennas that spot and see if they can see it, see anything. Hydrogen. I don't know what would change with a nova.
I don't know. A nova is a bright thing, like the sun. It may put out all kinds of stuff. Do we pick up any other stars in the sky, though? That seems rather dim for us. And so a nova may not be any different. Such a tiny point source. I don't see stars in my plots, so that may be difficult for us to see.
Oh, we at Bigelow, we are detecting stars all the time, at least like the OH emissions. So who knows?
Well, it'd be interesting to see if anything changed. We watch it, get a baseline before it goes nova, and then see if anything changed afterwards. Every frequency we can look at.
Hi, Rich. I've put a link there in the chat about the nova.
Okay, great.
Do you mind just I mean, I started to just in a bit. I said before I had nothing, but there are a couple of people who just started and we're to chat about what easy radio astronomy can do. Could I just show a couple of graphs that I process data, show them what the sort of output they get?
Absolutely, go ahead.
Wait a minute. I just need to work out how to get this share to work again. Right. Right. So first things first, can you see all those graphs appearing on there?
Yes.
Right. So for those that are new, never seen easy radio astronomy before, this is the output that you get out of it. One or two graphs, most of which, if you're like me, you don't have any idea what you understand. But this one I always find very impressive. So I'm in the process of mapping the Milky Way a second time round. These happen to be 1 week drift scans, but not that matters. It could be just 24-hour ones. And you can see there that there are 3 different elevations that I've used. And you can see how it's clearly on my 86 centimeter antenna. It's clearly peaking where the Milky Way is. And if you look over on this side, you can even see there's the peak is splitting because of the different sources down there. So the red dots are what my data, which easy radio astronomy has plotted over this rather nice background which Ted's provided, which is not my data, I would emphasize, which is just professional data showing that the radio sources in the Milky Way. Now, also, if you take it down, bear in mind, all this stuff is automatically produced. So just one other graph I want to show. If I can find it. Where's it gone? Where's it gone? Oh, it produces so much. It's a difficulty trying to find what we've got here. Really need Ted to explain it all, but where's the one? Ted, just remind me, what's the number for the one that's the map of the... Oh, here it is, found it. Milky Way arms. It's 570. So this is what blows my mind always. So this is actually the process of easy radio astronomy starting to use my data on just 3 different elevations, which you could do in potentially 3 days of drift scans, and starting to map out a Milky Way arm. And it's the red and the yellow is that arm there. It tends to only, because of where we are on the planet, we can only see roughly between 0 and 90. The rest of it is really not that open to us. But eventually, as I go further at the elevations, that curve that's starting to be produced there, the yellow curve, will start to spread further and further around to make a nice impressive picture of the Milky Way. The yellow dots.
And on the left, we start to see the next arm out, which is fun. So not just one arm, but several.
Well, that's why I'm doing it for a week
at a time. Out to the left.
Get that to come out better this time. It's like a CT scan, though. You're looking down from above as if you're outside of the Milky Way, which I just blows my mind. Anyway, there we are. That's what I wanted to show. Anything else you want to say, Ted?
Thanks for your help.
No, thank you.
Okay, any questions? Good. You're a good salesman for Ted. Let's see. Let me see.
Give you a second, Ted. If you could just say, I'll send you my address if you could send the check.
Oh, let's see. Rick from Deep Space Exploration Society. I hear you got a new antenna. Is that the one in the background?
Yes, that's the one, and I have a movie to share. If I can turn this on. We disassembled this 30-foot dish.
I don't think it's playing yet. Oh, there it goes.
So, what do you think of that? That's our new 30-foot dish, which which we delivered yesterday to our site in Haswell. There were 8 of us that disassembled this down to its smallest components, put it on 3 trailers, and hauled it back first to Colorado Springs, which was a 6-hour drive. And then yesterday we drove another 3 hours east to Haswell to our site and delivered all of it, the pedestal, the dish, all the feeds, the coaxes, everything. And we're planning, as soon as we recover physically, we're planning to reassemble it. And then eventually we're going to pour the concrete and bolt it down and get it back up in the air. This 30-foot dish will be a backup to our 60-foot dish, and will also serve as a daily EME platform, but it will be used for both EME and for space science as appropriate. If anything goes wrong, or if we have scheduling conflicts with the use of the 60-foot dish, we'll have this as a backup to do whatever we like. So we'll be needing to build new feeds because the gentleman who passed away and his wife donated this to us, used it primarily for EME on 432 and 1296, is my understanding. But we think we can do a great deal more with it than he did. So I'd also like to say the 8 people who disassembled this dish were between 65 and 85 years old. A couple of us have physical limitations on what we can do. But we spent 3 days on site after that crane lowered it to the ground, taking all of it apart and loading it on trailers. So age did not stand in our way. So that's what I have to report this week.
Thanks, Rick. And if anybody, Deep Space Exploration Society, if you want to hook up your system to that, there's just a plug-in in the trailer. Actually, they got a new building that you can actually bring your equipment and plug in and use the 60-foot dish. It has a very, very good tracking system. We can point at anything. It's a 0.8 degree beam width at 1450 or 1460 megahertz. So think about that if you want to do that.
Yeah, we
And
also have a new feed, so we're going to be doing 1600 also. Yeah, simultaneously, I think, with 1400.
yeah, I think it's a wide enough beam width.
Well, no, it's actually two separate feeds.
Oh, okay, that's better.
Yeah, well, we're experimenting with it. I can show you one other thing. The new feed, we wanted to be sure that it did the basic work. Let's see, is this it? Yeah. So we just went back and redid some a pulsar that we had previously done to be sure the new feed works. This is at the 1400 frequency, and we have a separate probe for 1600. We haven't used it yet, but we should be up and running with that in the next few weeks. Right now, this dual band feed is up and installed. Unfortunately, some of the parts that we need are sitting here. Whoops, can't show it, but our data collection boxes are sitting here in my lab, so I've got to get them back out to Aswell and install them.
Great fun, Rick. Good job with that pulsar. Okay. Let's see who am I get now. Preston.
I've got a question. I came in a little late because I was having audio problems. And the first thing I heard was, Rich, you said, that's all I have. So I was wondering if I missed news about the conference.
No, just the same statements about the conference and that we're running out of time of signing up. If you haven't signed up, if you are presenting, you need to get your papers in and presentations into Jay for the proceedings. And that's about it for the conference. And get your swags, from the saragifts.org. And that's it.
Okay, thank you.
Can I ask a question pertaining to the conference?
Sure.
How many people are attending in person? Do you know at this point?
Wow, it's I think we're filling up. We filled up the dorm. Oh wait, I'm sorry, you can't call it a dorm. We filled up the residence hall. I'm going to call it that. But yeah, that one's full. So if you show up, people have to go outside community in motels or whatever. And I'm thinking 30 to 50, and I've lost track. Tom's actually online. Tom, do you have any recent count of the conference? No, Tom Jacobs.
I think the last time I looked, it was about 40.
40, okay.
But I'd have to go back and look again. But I think it's pretty well. And of course, what I've got is I've got a single list that is both online and in person. And it's about even. So it might be closer to 60. But it's somewhere in that range. But I have a list that marks both of them, and I'd have to go back and look to see the two.
And those are people that are attending in person?
Actually, my list is of all attendees, both in person and online.
Okay.
So, and I'd have to go back and look at the list, and because I'm just keeping a single list. But I think we're somewhere up to, like I say, 60 or so, which about 30 or 40 of those people are online. But it's also probably close to 50-50. about between the two.
Okay.
events. Also, I'm going to guess that the people who are registering in person are probably done, since we're now in the late registration period. But we'll just have to wait and see. Also, I don't think I've seen any additional registrations since the 30th of June. And if anything after that has been online.
All right, Jerry, you thinking about going? It's gonna be great fun if you're
Yeah,
there.
I already signed. I signed up a month ago.
Oh, okay.
I was
Yeah,
just kind of. I'm giving everybody fair warning. I'm going to be picking a lot of brains, so I'll probably drive those 30 or 40 people nuts with questions.
That's it. Yeah, don't Drake's. That's what Drake's Lounge is for. And if you get ornery, we'll send you over to the 40-foot dish to do some measurements.
Okay.
All right. So, okay.
All right.
Thanks, Tom. You got anything else from the treasurer point of view?
No, not really. There are continuing people paying for their new memberships, and that's what's been happening mostly this month. So there's a constant trickle of people renewing, which is always a good thing.
We've gone from in 2 years, we've gone from 300 to 320 or so to 623 members. So we're expanding. So that's all good. And we're going up slowly because we don't go up too fast, because then that overwhelms the small team that's running this place. Okay. And speaking of someone who runs this place, Tom, how is you got anything? And how's the giving away our money stuff going?
Giving away the money. I like that. That's my job, is to give away $6,000. And to be honest with you, I'm doing a terrible job. We're not getting the grants that I'd like to see. So everyone on the call should find a few young kids that would like to get interested in radio astronomy and have them apply for a grant. I can think of turning down one grant in, oh gosh, I don't know, well over 5 years. And that one was just too hokey. And the committee was positive it wasn't a child. And I think he was just after money. But in any case, Super SID seemed to be going strong. Would like to see a few more Radio Joves in there. But those are the two big ones. Very, very few of the scope in the box, although the new scope in the box with the actual 1420 antenna works pretty well. So, hopefully in time, we'll get some more grants. We'll talk a bit about that at the conference. I'll see what I can do to get people to apply. On another subject, next week, I'm going out to Maui to install or do upgrades on Georgia Tech and the Space Force telescope. So that'll take me a week out there to get that done. But I don't look forward to the flight out, but being on Maui and doing the work is a lot of fun. So that's all I've got.
Okay. And so go ahead.
One thing that I've noticed is there's a lot of Super SID interest, and I wonder if this is somewhat related to the same thing with 10 meters, is that as we are going through solar maximum, there's a lot of activity, and therefore there's a lot of interest. Do you know anything about that, Tom? Is that something that you've seen in the past?
Yeah, I think the Super SID's Radio Jove requires a larger antenna. Super SID doesn't. I think that might be driving part of it. I know my Radio Jove is a dipole right now, and I've got a very limited space in the backyard, so getting the actual Radio Jove antenna up is tough. but I'm thinking about going with a Moxon and seeing if that'll get me another at least 3 dB a gain, but we'll see.
Well, I was thinking about 10 meters in ham radio. When during solar maximum, when the bands are open, 10 watts can make 10 meters a worldwide band, where at solar minimum 100 watts, and it's still a local transmission. And I was just wondering if that same thing has an effect on the supersids, and that people are seeing a lot of activity from the sun, and therefore they're interested. So it sounds like maybe this is not necessarily a correlation between people's interest in the activity of the sun.
I think that's got something to do with it, for the large number of supersids that are getting ordered. But supersids have always kind of led the way in the grant program, followed by Radio Jove.
All right. And Tom, you just got interviewed by Sky and Telescope. That happened yet? Tom?
Which Tom are you talking to?
You. Did you get interviewed, or there were emails about getting interviewed by Sky and Telescope?
Oh, yeah. I talked to the gentleman. He's looking for that out in about 9 months. So I told him that we'd be delighted to give him any information that he wants. That's on the itty bitty telescope, the IBT. And I asked him to send me the information that he has, and we can verify it for him. And
Okay,
I think
great.
for the IBTs, one in the past 2 years. So I'm not sure. We can talk about that at the conference if we want to continue that or not.
Okay.
18-inch 18-inch antennas are a thing of the past.
All right. Any more questions for Tom? Yeah, please reach out if you got any grant ideas. Please reach out to him, and you might be able to get money thrown at a student. And when he says young people, I'm thinking anybody below 50 is a young person. So I don't know about the rest of you guys.
I got a question. I taught for a while at a community college here in Northern Michigan, and I know they've got an astronomy program, but I've been kicking around the idea, would grants be available for the college if they want to, create a, radio telescope, or are they geared specifically for individual students?
It's geared for, we've done a lot of work with colleges, a lot of work with individual students. So it's whatever. With colleges, the largest grant we gave was in Pennsylvania for $5,000 to help them build a radio telescope. That took special dispensation from the SARA board, but we're more than willing to work with any college.
Okay, I'll reach out to the astronomy department here and see if they have any interest.
Yeah, one of the issues is that typically astronomers don't understand radio astronomy, and so they kind of don't understand it and don't want to do it. But we've had students in universities that have stepped up and done it. So we're delighted to do what we can to work with them.
Okay, thank you.
And you have to understand, our goal is not to turn down any grants. We will work with whoever to get them to write the grant so that we give it, and that they have the knowledge and support to be able to make them successful. I've worked with 2 students here in Georgia with the scope in a box, and they've both really done well. Where I live, we've got a couple of retired college professors. I've passed the paper to them, and they're telling me, "Oh, this is nice work for a grad student." Say, "No, it's a junior in high school." So the kids today and the resources they have are so much beyond what you and I had as kids.
Okay. Thanks.
Okay. All right. Thanks. Thanks, Tom. Mike
Sure.
Kaba. You're on mute, Mike.
Unmute. Okay. Can you hear me?
Yep, go.
I was curious about the Sky and Telescope article. I may possibly be connected to that. My sole experience in radio astronomy is with the itty bitty radio telescope, which I built to do I substitute teach at a local school, and I just built that to do a proof of concept that the sun puts off more than just visible light, just kind of a simple thing. And then I just happened to take it as an afterthought to an outreach program that I was doing for solar with white light and H alpha. And then turned out that the itty bitty, which I took to it, was kind of the hit of the observation or of the session. And somebody said, well, hey, this is really cool compared with those other scopes. And the itty bitty, you know, cost you $200, and the other stuff, you got a few thousand in it. And so I thought that was really, really interesting. And so what I did, I've been published in a number of different periodicals over the years on subjects other than astronomy or radio astronomy. So I'm always kind of looking for interesting articles that, you know, just to pitch. And so I pitched something to Sky and Telescope, and they switched me over to a fella that does the astronomer's workbench. And I said, hey, look, you might be interested in doing this story here. And he said, yeah, he would, but he needed to check it out with somebody from SARA to make sure that we weren't infringing on copyright. And that may
that sounds good. Yep.
That he talked to. So it's a small world. I just, my sole experience with radio astronomy is in the itty bitty radio telescope, and I just ordered SARA just because I found that so many people were interested in it, or Super SID, just to kind of explore that area. So I'm a newbie, double newbie. But it's interesting. The guy from Sky and Telescope may have called Tom to see if there was copyright or patent issues with the itty bitty, and then he got back to me and said, no, we don't. They don't have any problem. We're going to write the article, and the article is about the experience that I had building this thing, and then displaying it at a public event. And then the interest that I got, which surprised me, you know, and so that may be the connection there. I don't know. What was the gentleman's name that contacted you, Jarek or Tom?
Oh gosh, I don't remember off the top of my head, but it's a guy that's going to do the article, so it's the same guy.
Yeah, it's the same guy. So that's funny.
Yeah,
I don't know.
What I told him was that, you know, we thought it was a great idea that he publish it. SARA doesn't have copyrights, and anything that SARA has is pretty much in the open domain. It's up to the individual in SARA who, you know, who's putting something out there if they want to restrict it. But the itty bitty, oh gosh, I've built, I don't know, 100, 150 of them so far.
Yeah. It's a great little tool for proof of concept to, like, I just substitute teach at a middle school, and I just did it because during the day you only have solar to observe, and so you have one object, and I was just looking at different ways that you could look at this same object: white light, H alpha, welding glass, and whatnot. And then I discovered this itty bitty that can detect the sun, so I threw that into the mix, and then it just took off from there. So it's a really interesting thing. If you want to, I don't know, everybody here is showing video. Maybe next time I could show you the video of of if anybody wants to see it. It kind of surprised me, so that people were interested in it as much as they are. And then they come up and they turn the table and hear the frequency change and all of that. It's kind of cool. So anyway, that's the surprising connection. Small world. So
what I do is I modify the sat finder so that you can take the output to the audio card on the PC.
Yeah, I'm a newbie, double newbie. I built it for probably less than $200 and just because it was just a proof of concept kind of thing. There's probably many ways to do it that are much more advanced than what I did, but it's kind of a entry level for me to get into radio astronomy. I do lots of optical and then just educational presentations. But so I joined SARA just because of what I saw with the interest in that, and then ordered that Super SID just to kind of continue the pathway of discovery and learning. Yeah, I don't know if anybody wants to see that, how it works, or if everybody's already seen one. I just have a 10-second video that I could show next time if anybody wants to see it. So
I think we'd be interested. The other thing is, if the Super SID is going to be used for the school, go ahead and put in a grant for it.
Well, I already ordered it. I mean, I appreciate the offer, but I'm not sure that it's going to be used for the school or not. For me, it's just kind of a personal exploration. I built the itty bitty for the school, and then I was just going to dismantle it and store it under my bed until next class, next year sometime. And then, but then I didn't take it apart, and I just threw it in the car and took it to this event, and then it just kind of developed legs of its own, because people were telling me, well, this is more interesting than the white light, and H alpha and white light were showing well that day. But they got to turn the deal and hear the whoosh or the change of pitch and all of that. And so, yeah, so I'm just kind of exploring this new area within the field. And Tom, did you say you did want to see the 10-second video maybe next time, or is that?
I think that would be. I think everyone would be interested.
Yeah.
Oh gosh, 5-10 years ago, that was pretty big. We were building them for NRAO for Green Bank, and we'd have 15 or 20 people at the Green Bank Star Party build them. So the issue today is that 18-inch dishes are hard to find.
Yeah, I got mine off of Craigslist for somebody, and for $25. And so what really amused me was, I have $200 or less in the itty bitty, and then in my white light and H alpha stuff, you got a few $1,000 over there, and people were saying, well, this is really cool, and I'm thinking, it's a couple pieces of plywood and an old satellite dish. It's just, it was like.
Take the 10-second cut and put it on TikTok.
I don't have a TikTok deal. I'll show it to you guys. And I cut it down to 4 seconds because
that's too short. 10 seconds is about perfect for TikTok.
Yeah, well, I'll show it I'll bring it to next month. This is my first time. I joined SARA on like Thursday. Okay, this is for Wednesday. So I'm like newbie on double newbie, whatever it is. But it was fun, and it's a whole new interesting thing to learn about, and it's kind of a gateway into something like that. It's kind of a gateway into radio. So I'm just one step inside the gateway. So I'll bring it next time. And then if anybody wants to put it up on TikTok or advertise or whatever they want to do, that's fine with me. I'm just as surprised as anybody. It's fun. I was really surprised at how much interest there was. That was cool, but this is really cool. It's like, anyway, so I'll do it next time if that's okay. Yeah.
Yeah, you don't have to wait a month because the next meeting is, I think, in 2 weeks, right? The Drake's Lounge.
Drake's Lounge. We got another one that, yeah, you can show it then. And then we got Drake's Lounge Australia that next Friday. So
it's Drake's Lounge. Remember, I'm a 3-day member. What is that? Is that like this?
This is sort of aimed for your observations. Drake's Lounge is more of a technical side where people start, I'm trying to get the engineers and the observers split up a little bit. Yeah, you could show it then. That's fine. You'll get a notice, and you'll get a notice about a week ahead of time.
Or I can send it to somebody and well, I'll check out. I can do it on Zoom. I'm pretty sure. It's just, yeah, it's a cool thing. I mean, it's really kind of fun. So,
all right.
Yeah.
Glad you have you on board, Mike.
Yeah, it's fun to be here. I've got a lot to learn.
All right. Okay, thanks. Let's see. Who am I? Bob.
Okay. Hello, everyone. I've got something I wanted to share with you. I've been working on software for my magnetometer, and this is my plot. So I'm doing, it makes me feel like a real minor thing compared to looking at some of the stuff on that Ted has done. But I spent a lot of time with Python and the plotting packages that go with it. But this is a 3-axis magnetometer that you can get from tapper.org, which is part of the HAMSci project. And so I've got it buried in the ground about 4 feet down. I think the magnetometer goes for about $130, something like that, with the 3-axis magnetometer. And axes are plotted here in X, Y, and Z. On my screen, the right-hand side was cut off. I moved it over some. Hopefully that'll make it show up for everyone. But this is on the 6th of June. And I've included in my software the sunrise, the noontime, a line showing exactly when noontime was and sunset. So we're looking at our star here, and there's been a lot of talk from different aspects of the sun today, I've noticed. But on the 6th of June, it was a fairly quiet day in terms of the sun's recent activities. And my theory was that at noontime, we would have sort of a flip in the magnetic field, plus or minus a difference in the tilt of the axis of the Earth. And sure enough, I think I see the fields switching polarity here. This is on a scale of nanoteslas, and there is a fair amount of noise in it. And I'm out on a ranch, and so I've got this sensor buried in the ground pretty far away from anything else going by, cars or any other kind of steel or things like that. And its data is being collected by Raspberry Pi and fed back on the internet. And as of now, I've got about a year's worth of data. It took me a long time to get around to doing the plots and actually start looking at them. But now I've got this interactive program that I can dial up any day that I want to and look at the data. The green line on here is the temperature in the ground at the sensor. So it's staying flat at 4 feet down. The red line is the temperature up in a little, kind of like a little doghouse thing that I built to put the Raspberry Pi in. So that's the ambient temperature variation during the day. And let me see if I can share a different one. So I also have these sensors that are this receiver system that's listening to WWV, and essentially it's looking at the changes in the ionosphere through the day. And you can see like at sunrise here and then sunset, but it's a very stable, calm day. But on a day that there's more sun activity, you'll see a lot of variation in this and perturbations. And so I felt like those two complemented each other. Anyway, that's what I wanted to show from my observations.
Thanks, Bob. I do have a question. Are you guys able to see the pole shift? I mean, everybody's talking about the magnetic pole shift. Is that something we would see just besides the solar activity and things like that? But
Yes,
that should have a dramatic effect on this magnetometer, right?
yes, it would. And the pole shift, though, is going to happen over a very long period of time. But yes, you would see it in the axes of your data, because it's going to, just like I just showed you, the change that I think is happening because we're swinging through the magnetic field of the sun on the Earth. And that's what I'm really looking at here, is what the impact is of the sun's magnetic energy is on the Earth. And it jerks the Earth's magnetic field around quite a bit, especially if you have a big ejection or a big solar wind come through. It can just really bend the Earth's magnetic field around. And I think one day one of those big bends from a flare from the sun could cause it to flip over and just not come back around, possibly. And it's supposed to be a pretty dramatic thing when it happens. It could be, it'll impact the satellites and a lot more potential for radiation on Earth. And it's just another one of those big things that if it ever happens, you won't like it, you know. But it has happened before, though, too. They can see that in the steel and things that are in deposits in the Earth and trace it back to the moon.
And we did have, they said it was close to a Carrington event, but it wasn't just recently. Did you look at that time period?
No, I haven't looked at that, but the Carrington event was a reversal. That's the final.
Yeah, but there was one just recently that they said just was a bare miss for being a full Carrington event from a solar
flare. It was very strong.
Yeah.
In the X-class flare. We've had several this year, X-class flares. We're real close to the peak of the solar activity right now.
Okay. Any questions for Bob? Okay, thanks. Charles. Charles is our historian, by the way. So if you've got any old pictures of events or pictures of the current events, send them to him, and then he writes an article on them. And I think we caught him on a break. So let me see. Anybody else I did not touch? Yeah, Mike, go ahead.
Hey, I pulled that video up of the itty bitty. If you want to see it, it's just a 10-second video.
Go for it. Go share it.
I'll try to do that. Let's see if I can screen share. Share basic share. Open system. It's going to come up. It will come up. I've shared this on other. Go ahead.
Share the window that you have it running in.
Okay. I think I have it on my. Hold on. If I can't get it up now, I'll figure it out. Hold on. I'll try one more thing here. Share sound. Share slide as virtual background. I can't get it. I don't want to take any. Yeah, I don't want to take any time, but yeah, it's not coming up. But anyway, it's simple. So I'll show it some other time.
Not a problem, Mike.
Okay.
All right. Anybody else that I didn't get yet? Charles, you back on? No? All right. Last but not least, we will have elections. We've got 4 board members and 2 officers that need to be elected. Nominations are still available, or still able to nominate people. Please, if you nominate somebody, ask their permission first. We can always use the help. If you want to not be an officer on board, contact me. We can always make you a committee member, and you have for special projects, whatever you want to do, and we can get you involved in the inner workings of the SARA organization. Okay. And with that, thank you very much. Next meeting's Drake's Lounge in 2 weeks. That next Friday. So we have it Sunday, 2 weeks Sunday. Then that next Friday is Drake's Lounge Australia. Those guys are always a blast to talk to. We'll see you guys then. All right. So see you later.